Great. Let's see when we shall start. We will give it a few seconds here, I think, before we're starting. It would be great if you all could post a comment whom you are and where you're from. So I will start. Hi, everyone. Viktor Eliasson here. Diadrom Software. So it's just following the white rabbit or Viktor Eliasson there as well. So 1 minute have gone. So I think we will start. So welcome to the webinar today. The topic today is, the headline is Diagnostics Want to be Free. And that's a thing we like here at the Diadrom, Diagnostics, and we also like to share our knowledge. So I'm Viktor Eliasson, CEO of Diadrom Software. We have own IP related to automotive software when it comes to embedded devices, test and verification, but also aftermarket solutions. So I'm really glad to have you here today. Welcome. We're also going to be joined by our senior diagnostic expert, Marina Bylov, later on, who will demo our newly released open source software. So it will be really interesting. So first, of course, we have a small walkthrough what open source software is, the initiative from Diadrom, the project overview, and then we will go into the demo and some intro by Marina, and then we will have some Q&A session if you have any questions, and then we will close the webinar. So let's start. So as the famous open free commonly said, ask not what your community can do for you, but what you can do for your community. And that's where we start this webinar with this statement. I think you can recognize it. It's been rewritten, as you can see. So about open source software then. Open source software. It's open source could be either a software or hardware as well. It means that something is released under a license, which have a copyright holder, which grant users to use, study, and change, but also distribute software and source code for any purposes. So this is a concept from beginning of the 50s or 60s. However, the bearded man in the right probably made it possible as it's today. It's Richard Stallman who founded the GPL license, which started this in the 80s. Then it was a free software. And one of the early adapters or big successes was the Linux kernel, which was built by Linus Torvalds. I reckon many people know about this. And in the 90s, I think there was a doctor named Christine Pettersson who changed the free to open source instead, because open source isn't free. Some open source is free, but not all of them. So open source software, it's not about just adding source code on GitHub. It takes a lot of maintenance, a lot of strategy, a lot of direction if you should take the software into open source and also on GitHub. Many things you can just add the source code and it will be a living creature following. It's not free software. Many of the open source software is under different licenses, which you have to license to use in commercial environment. However, most are as free as it could get without paying anything. Many people think it's a way to lowering your maintenance cost. However, as I said before, it takes a lot of resources to orchestrate this kind of maintenance setup. So if it's cheaper, I'm not sure, but there's a thought among the people that it should be lowering maintenance cost, and I'm not sure about that. But open source software is about driving innovation. It's about cutting time, reusing other people's source code and technologies. It's of course to reduce cost in the long run. If we build up on each other's solutions, we can reduce cost by reducing developing bits and pieces of software instead of adding modules into our solutions. It's also part of empowering developers. I know that many developers are really sick of not having access to the source code and could make minor adjustment or added code by themselves. So this is a way to empower your team and developers, and also then cut the middleman to do change requests, etc. But it also finally it's a great way to increasing adoption of standards, as we're going to speak of today. We will release, or we have released, a standard diagnostic over IP, which is a 13400 ISO standard. So this is also a way of increasing adoption of a standard. If we can help the industry to adapt it faster, everyone will gain from it. So our project then is going under the banner Diagnostics Want to Be Free. Diadrom's core niche and expertise is diagnostic of autotech, where we do handling software throughout the product lifecycle, and this is just a small part of it, where we are contributing for a safer software-defined vehicle. So then we are really proud to present our first open source project, which is a diagnostic over IP, DoIP, which are now located on GitHub and also as a nugget package. Or packages, sorry, there are several packages. So to quote myself here then, it's really nice, of course, but of course we want to invite developers worldwide to contribute to increase the development and the pace in vehicle diagnostics. So of course it will also in the long run enhance safety and reliability of software-defined vehicles. But also it's a part of a brand image for us going forward. As a niche player in this area, we want to contribute with our expertise in a greater way to the community. So the software-defined trends are we are going to have increased ECU consolidation, which are creating bigger computer units. We feel that diagnostic over IP will be a standard which shall be adopted in these kind of ECUs. But we also see software volume and complexity growth, and therefore, of course, we want to add our expertise to the community, so the complexity will decrease. But also the third trend is a value chain collaboration, and this is probably the biggest point here. We want people to add stuff upon our technologies and contribution to the community, so we all could thrive in the future. So, and also In some case, this is also benefits for potential buyers and users, which reduce costs, increase agility, but also accelerate development timelines. And that's what we are doing here at Diadrom Software daily. So great. Now I want to introduce our senior software engineer, Marina Bulov. She's going to do an introduction of herself and then walk through what we have put up on GitHub and Nugget as well. And she also going to run a demo. So welcome to the stage, Marina.
Thank you, Viktor, for a great introduction. It feels great to make this webinar with you. I've been here at Diadrom almost 10 years, and I work mainly in aftermarket world, building aftermarket tools. So I want to say that the Diadrom has been in automotive industry for more than 20 years. And just to give some history about how we decided to go open source, is that we review what we have on our repos, and we discovered diverse diagnostic related tools and libraries. Many of them can be considered legacy, but still they're good shape. So probably we will give them a second life, and we will make them open source. So for the first project, open source project, we choose a service that is called Diagcom and represent a vehicle diagnostic communication service that has support for DoIP and UDS protocol. So it is published and documented on GitHub, and I don't know if you see my screen. I think, Viktor, is it shared?
Now it's shared.
So it's a public Diadrom repo on GitHub, and it is freely available to modify, learn from, and to use in other projects, as you said, Viktor. It is as well packed as an installer and .NET and Nugget package for those who want to try or to use it as it is, or to build proof of concept with it. It is documented, so we have README file, and we started as well to build a wiki where we describe our API and endpoints, so with examples and exact responses and payloads. So as I said, it's an installer and a Nugget package. Installer will install the service and will run it as a Windows service on localhost. And the Nugget package, it can be imported in .NET application and use it as a library. Again, well documented and examples on how a vehicle can be identified and common to use. As I said before, it's DoIP and UDS protocol that is supported by our vehicle diagnostic communication service. So I will give some context on what is diagnostic over EP. And so DoIP is a standard vehicle interface which separates in vehicle network technology that can be CAN, FlexRay, or some other standards from the external diagnostic equipment, which is diagnostic clients and tool. This standard is well known in the automotive industry. It describes features that can be used to detect vehicle on network and enable communication with vehicle gateways. So when we talk about gateways, we talk about DoIP edge node that are hosted inside the vehicle where Ethernet starts or ends. So depending on the architecture of the vehicle, it can be one or several DoIP edge nodes in a vehicle. It's a standard, it's a 13400 standard, ISO standard. And just to give an abstraction on this DoIP, on transport layer, it has TCP and UDP protocol that is implemented. So it is nothing more than a client-server architecture, which is built in the vehicle, and the tester is a client. So if we look at the vehicle that recently got connected to an test equipment, edge node will start broadcasting an UDP message that is nothing more than vehicle identification information. In our case, Diagcom, which is the vehicle diagnostic service, will receive these messages and will extract information about how to connect a vehicle. And based on this information, a TCP connection will be established and diagnostic services can be run. And now diagnostic services is another standard which is also well known, not just in automotive, but also in the whole diagnostic world. And it contains features about how to read and clear fault codes and how to read write data on ECUs and download, upload software. So it's just a request response based communication, also as well known as client server communication. So if we can imagine diagnostic services, they are packed and sent through DoIP messages to vehicle to gateways, and a response is received by this DoIP edge node. Just in this context, I just wanted to say that DoIP standard is not necessary to know when you are using packaged Diagcom. But in case the source code will be changed, or if you need to change the logic implemented in this Diagcom solution, then you'll probably need to know something about ISO 13400. Yeah, but not important to know about DoIP, but it's important to know about UDS because our interface is based on UDS protocol. So I will go to my demo.
Yes, let's see. I will add your screen here, Marina.
Thank you.
Yes.
I already run the installer, and it's, as I said, it's a service which can be accessed and explored via browser, and we have documented it on Swagger. So on one side we have the service, and on another side I will take up. It's a simulator, vehicle simulator. We have a Diadrom. It's nothing more than a TCP and UDP server that sends, receive requests received from the service. So here I have two vehicles just to simulate multiple vehicle connections. So I have one vehicle with this VIN and another vehicle with which ends with 1. They both run on localhost, but you can run it on another IP, and they are not on the same port, I think. Anyway, if we run our service and we want to see connected vehicle on the network, so we will run our endpoint, get connected vehicles. And I don't know if I should run a clear before I can run it here again. So we see our two vehicles that are on our network available. So this is nothing more an UDP client receiving two packages, one with information about one vehicle, another with another vehicle. And probably if you will detect a vehicle, you would like to run some diagnostic or some operation on a vehicle. And let's try to use our predefined operation, which is called read and clear diagnostic fault codes. And here we have Swagger is very good because you can explore and try different payloads. So I prepared already few payloads, and here I will run read clear DTC on this vehicle with a clear operation on. So when I will run execute, it will run a functional read DTC operation, which is service 19 in UDS. And you just this predefined operation returns all the ECUs that answer to functional service 19, and in case there are fault codes, they will be translated and displayed with correspondent flags on or off. So yeah, this operation is predefined as I said in our API, but we have as well possibility to run raw data requests, and here is some example on how to run the same operation as raw diagnostic sequence. So we have the vehicle, the operation will be run ECU address. Here I gave functional just to show how ECU will answer to these requests. And operation, which is 19, service 19, which gives responses with fault codes on. I think almost all ECUs have support for service 19. That's why I choose it for demo as well. So if I run it, I get in the raw data there is address, source address, and the response. And as you see here, I have not mocked in our simulator all the answers, so we will have not supported negative answer with not supported for few ECUs, and we have this ECU that answered with two fault codes. So yeah, it's as you see, it's a byte arrays that are returned from all the ECUs, but we have actually a parser. Probably you will not want to see all the time byte arrays. So we have implemented a parser, and it's called Diagnostic Services. And this example I have on Wiki as well. And for example, we as a payload, input payload, we have to specify the service we want to run together with data identifier. For this example, I choose this one, which is random. So probably it will not be a complex parameter we will read. So each data identifier can contain one or more parameters. So for this data identifier, I choose an unassigned parameter, and I gave position and total bits we will assign for this parameter. So I run execute, and together with raw data, we have the value, which is an assigned type. Yeah, this was my demo, and I think I have one more slide. I don't know if there are any questions on this one. Probably we will take it later. I don't know, Viktor, what do you say?
Yes, we will see if we have any questions to sum up later on. Otherwise, people are free to send us an email later on as well.
Yeah, then we can go on our ideas how this service can be used, and there is many possibility to to use this tool. Is just few of them we want to notice, and it's proof of concepts or just individual use to run fault codes or clear fault codes. Again, for automation tests, integration tests, diagnostic system tests, all of these kind of automation tests that are very important when ECU are built are available to run on this service. So just in case it needs modification, it can also be done on source code on GitHub. We're also thinking about having implementation for another standard. It's E2534, which has support for CAN, but probably it will come later if we see that there is a need for it.
What I think is quite impressive was that we have just done the installation and then picked the OBD Ethernet cable and went out to several of our cars and picked up diagnostic, did some diagnostic services on it. So for me, it seems quite straightforward. So I'm super impressed by the work. But as you said, there's a lot of possible solution how you can use it just via a switch or whatever. You can test several different ECUs, right? If you use it as a subsystem testing tool as well.
If the nodes are connected to this edge node, yeah, everything should be through edge node. This DoIP edge node that implements ISO standard version 400.
Correct. And of course, next step would be to do this remote, right, via Wi-Fi or something. Would be interesting to add in the future. That's possible, right?
There is different alternatives for remote connections. We haven't tested yet all of them, but one option would be that the service sends information to some other service that is remote connected, and then this remote server can dictate what to run on the ECUs. Another scenario could be that I probably will not go in details because it's network related and firewall, and it's probably you could detect vehicle on the network, but we didn't try this scenario.
No, but it's an interesting area to.
Absolutely.
If someone is interested, of course, it's a possibility.
Yeah, it was out of scope for this just this service, because there are operations that we still think that remote would we still need reliable connection, and this reliable connection is ensuring that the software download and processes are run locally on local machines. So right. you will not probably it's possible to this scenario we want to cover is when we run software download through UDP connector.
Yeah, correct. Because we're also able to help with the software download part, but this is not a part of what we have done on the release. But because it's a lot of proprietary stuff and also like security access, there are
I think almost all the new cars have over the air as well, which is another way of updating and running diagnostic on the ECUs. This scenario we're talking about is the workshop, and probably manufacturing and R&D, which will run their diagnostics over UDP connectors.
Correct. And regarding the simulator, do you have anything interesting to say about that one, or is there
Absolutely.
something you want to promote?
Yeah, we have two simulators, one on DoIP, one on CAN, which we probably will upload as well. It's a possibility to try it, and also this service we released, it's easy to test and explore with the simulator. Otherwise, you would need a vehicle. And as I said, the DoIP is well known, and probably if you didn't check, your car has already it. You just didn't know about it.
Great, thank you, Marina. Super.
Thank you.
The demo ghost wasn't there, luckily. Great. Sometimes it shows up, but super. Thank you. And this is, of course, just a part of our offer. What we talked about today is one of the 5 areas which we are looking into when it's the software-defined vehicle, and it's the communication offboard mainly. Of course, we have offering in all the areas, but this is mainly for the communication to the vehicle. So that's one of the areas. And of course, as Marina showed before, Diagnostics will play a critical role in the future as well, now maybe on different technologies like DoIP, Ethernet, etc. Because it, of course, increases efficiency, safety, but also improves reliability of software for our products. But also, of course, it's a possibility to reduce operational costs. We don't have any, we can test and verify the cars and do not get any callbacks, etc. But of course, in the end, why we all here is that we will give the end user a great experience of the product. So still, we will be really critical in our customers' deliverables. So yes, yeah, I had some questions when we spoke about the other slides. So I don't have any questions really now. And I don't see any questions from the audience. We can wait a few seconds maybe if we have any questions. Otherwise, we are going to send the presentation and the recording. And if you would like to any more meeting or questions, just let us know and we will answer your requests. And if you're not already new, we have a diagnostic book on our homepage with other knowledgeable stuff like white papers, etc. But also you can find other webinars on our YouTube channel. So feel free to Google it and subscribe to it. Great. And if you have any questions, etc., give me an email or call and I will take it further with my colleagues. So thank you, everyone. And thank you, Marina, for a first great webinar made by you. Really great.
Yeah, thank you.
Take care
Bye-bye.
now. Bye-bye.